Welcome to the last breakfast. Please enjoy the video.
You start by confirming your environment. Check that an NVIDIA GPU is present and drivers match a CUDA toolkit. Once done, install Pytorch built for your CUDA version via pip or conda so binaries include GPU kernels. Then immediately verify in Python, import torch, check torch. CUDA is available, and print the device name and memory. This step prevents wasted time later and ensures the runtime will accept tensors and modules on CUDA devices right away. Now make your code GPU ready by defining device equals torch. Device, CUDA, and moving the model and inputs there. Transfer the model with model. To device and tensors with tensor. To device non-blocking equals true. This reduces host device stalls. Use data loader pin memory equals true to speed host to device copies. Enable automatic mixed precision with torch. CUDA. AMP. Autocast for faster and lower memory ops and set torch. Backends. CUDN. Benchmark equals true when input sizes are stable to gain kernel selection benefits. Finish by running your training loop with data and model on device. If using mixed precision, wrap backward and step with torch. CUDA. AMP. Grad scaler. When saving for portability, move state dict to CPU or save model. State dict, directly then export. Finally, validate inference on GPU. If you hit out-of-memory errors, reduce batch size or use gradient accumulation, enable torch. Backends. CUDN. Enabled tweaks. And call torch. CUDA. Empty cache. Between experiments. Driver.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.